Hello students, today we will see what is the Kirchoff's voltage law and Kirchoff's current law. So for Kirchoff's voltage law, we will also call this one as a KVL. So for Kirchoff's voltage law, I will draw the circuit like this one. So for this one, we have the voltage source, that is plus minus V1, and the three resistance R1, R2 and R3. These are connected in series configurations. So the Kirchoff's voltage law will state that the algebraic sum of voltage around a closed loop must be equal to 0. So already we must know that this is a voltage source. So current will be flowing from positive to negative. So I will mark this one as a I. So after flowing through the currents, we will mark the direction of currents in terms of polarity. So here I will write down plus minus, plus minus, plus minus. So current will be flowing from positive to negative. So if you observe R1, R2 and R3, all these three resistors are connected in series configuration. Already we must know the Ohm's law, that is V equal to I into R. So I equal to what? V by R. So the Kirchoff's voltage law will tell that algebraic sum of voltage around a closed loop must be equal to 0. So here we will start for the writing. Here the voltage drop across R1 is V1, voltage drop across R2 is V2 and voltage drop across R3 is V3. So we will start writing here. So here this is a plus sign. So I will write down plus V1, again here plus sign, plus V2, again here plus sign, V3. So I will start from here V1, V2, V3. I will mark this one as a V. Then it will come to V. So here we have the negative sign. So minus V equal to 0. So I will modify this V1 plus V2 plus V3 equal to V. So already we must know V equal to IR. So we will just put it here. So voltage drop across R1 is V1. So from R1 the current I will be flowing. So I will write down V equal to IR. So here for V1 we have R1, again V2 equal to R2. So I into R2 plus I into R3 equal to V. So I will write down this one V equal to I will take R as a common, R1 plus R2 plus R3. So I equal to V divided by R1 plus R2 plus R3. So here from this equations we will state that the algebraic sum of voltage around a closed loop must be equal to 0. So we will see one problem on this one. So for Kirchoff's voltage law, basically it will depends on the loops of currents. So for this one I will give find the value of I using KVL. KVL stands for Kirchoff's voltage law. So I will draw the circuit. So for this I will take 4 resistance and one voltage source, that is plus minus V equal to 10 volts. Then here I will mark R1, R2, R3, R4. So already we must know the current will be flowing from plus to minus. So this I will mark as a I. So always KVL will work on the closed loop, not on the open loops. So here, so I will mark the direction of current in terms of polarity. So here it is plus minus plus minus plus minus plus minus. So I'll mention R1 equal to 5 ohm, R2 equal to 10 ohm, R3 equal to again 10 ohm, R4 equal to 5 ohms. So I will start writing the equations. So here we have V1, V2, V3, V4. So start from this side, plus V1 plus V2 plus V3 plus V4 plus you will come, it is minus V equal to 0. So V1 plus V2 plus V3 plus V4 equal to V. So V1 I will write down I R1 plus I R2 plus I R3 plus I R4 equal to V. So I into R1 plus R2 plus R3 plus R4 equal to V. So I 5 plus 10 plus 10 plus 5 equal to 10 volts. So I equal to 10 divided by 5 plus 10 plus 10 plus 5. So 10 divided by, that is 30. So I equal to 10 by 30 amperes. This is the final answer.